Alright, so in our first video, we've found the relationship between m and c for a linear function such that the area bounded between the linear function and the quadratic one has that relationship, like the one above the line and uh, the two areas above the line were equals to the area under the line between and above the quadratic. So that's the relationship given to us. So we use that and use some interesting integral technique to find a relationship between m and c. So for that relationship, that means if the line has the gradient equals 4 minus c, which is the y-intercept, then that means the area a plus 3 will equals to the area of 2. Alright, so let's move on to our next question. Alright, so that's part A we've done. So remember, for part A, the answer we've got is c equals 4 minus m. That's what we've got. Alright. Oh, wait, we've got m equals 4 minus c, but another way to write this is c equals 4 minus m. Sorry for that. Okay, the same. Okay, the next one is, now we are going to restrict our m as m equals 0.1. And that's okay, because we understand at the start of a question, m is between 0 and 1.3. So it's okay for us to make m equals 0.1, right? And so we need to find the values of alpha and beta. First of all, what are alpha and beta? Remember, alpha and beta, they are just the points of intersection between the line and also the quadratic graph. Okay, and let me remind you that quadratic graph is what we call y equals fx equals x squared, and that straight line is y equals gx equals mx plus c. But right now we understand the c is equal to 4 minus m. That's what we've got here. So you need to find the intersection point. And so, of course, algebraically, you can always do it like, can we solve it when m equals 0.1? So y equals x squared, and y equals what? Remember the straight line equation, you have m equals 0.1. So that means when m equals 0.1, and you should have y equals 0.1x plus 4 minus 0.1, which is 3.9. Alright, so can we solve it? 0.1x plus 3.9. So of course there are a variety of ways of do it, but I'm going to show you how can we do it in Desmos. And of course, you can use your calculator to solve it, or some of you would like to use manual math, but the quickest way to do is Desmos. And I always need you to do a full working without technology. Determine R1 and R2 and R3 when m equals 0.1. Okay, but let's go to Desmos first. Okay, so in the Desmos, I'm going to plot the two graphs. One is, okay, let's say is fx, which is our x squared. Okay, that's a quadratic one. Then what I'm going to do another one is gx, which equals, okay, it should be mx and 4 minus m, right? Okay, so let me use 0.1x plus 3.9. Okay, then you will see that two intersecting point here. And you can click on the point, then you will get the value. Alright, but if you want that the Desmos actually show you the point, you can always go to the inputs here. You can put fx1 and use that symbol equal gx1. Okay, then it will show you immediately x1 equals one of the two values. And okay, so that value is here, 2.025. But you would like to find, how can we get Desmos to help me to find the other one, minus 1.925. Okay, to do that, first you need to restrict your domain over here. You can restrict the domain. Like I say, okay, the one of the x value should be greater than 0. So, oh, sorry, it's just, let me do it. Okay, it's greater than 0. So I'm going to here, greater than 0. Okay. Oh, sorry, I forgot to put x1 here. Okay, then it will show me the one greater than 0. But how about if I want to find the one less than 0? And you can do it here. You just copy and paste. All right, but this time can get you to. Okay, then you get another one. But of course, because that's another point, I would like to set. Okay, I'm just swap them because I would like this one to be my x1, which is alpha value, and the next one be my beta value. So I want to make some change. I want to call it x2 rather than x1. So I call it x2. Okay, then you will show me the x2 value. Right now, I've got two x values as the intersection point. One is x1, the other is x2, which are corresponding to our alpha values and also beta value. All right, so that means if we go back to our notes, and you can say things like, okay, so my alpha value, so my alpha value is just minus 1.9257. And my beta value just 2. Okay, so these are two values of alpha and beta. Okay, so the next thing is, can we show the full working to find the area 1, area 2, and area 3 without technology? Okay, right. So you know, to do it without technology, you need to go with what's F1, also A1. So A1 is the area below Fx, but above the Gx, above the straight line. So you will go like, all right, it's Fx minus Gx dx. All right, from where? From your minus 2. Is it minus 2? Let's see. Yeah, minus 2 to alpha. Okay, to my alpha. Okay, but we've got alpha equals minus 1.92547. Okay, and my fx is x squared. My gx right now is 0.1x. Okay, because it's take away gx, so that plus 3.9 become minus 3.9x dx. Okay, and of course, you can solve it manually. You can do a lot of work without technology. It's just purely integration exercise using numbers, but it's very tedious. So I'm not going to do it here. Sorry. So what I'm going to show you is that, so since this is so tedious, so that means it's very easy to make mistakes. So can I show you a way to find the area using the Desmos? That's what I'm going to show you. Is that okay? Right. So let's go to the Desmos. All right. Okay, since we've defined what fx and gx, okay, so let's do it like I'm going to go to the Desmos. I'm going to the function. In that function, you will see you go to calculus and you see integration here. So let me click the integration template. So you will see there's some integral, and you input your lower limit, which is from -4, okay, to 2. Oh, sorry, not to x1, okay, because x1 is the value which we've been used as x1 is minus 1.92547. Okay, so don't forget the bracket. So then you have that one. Okay, then you automatically you show you the value. All right. So that's my area 1. Okay. So if you want to have some kind of remark reminding you that's area 1, okay, you can always add some notes. You say that's area 1. Okay, is it? Okay, so let me put that area 1 above the integral. Then I'm going to copy that again. I'm going to add here. Oh, I can't do it. So I have to, sorry, I have to input that again. Sorry. Okay, so that will be area number 2. So another code. All right, so what would be area number 2? You don't want to click those templates, do you? So you can copy and paste. Sorry, let me get this disappear. All right, but this time, what I'm going to do is x1, 2. All right, so you see that should be in the region of the second, that means the beta value. That's the second area. That's from x1 to x2. So from this point, that's x1 to that point. All right. So basically, you get the area 2. So you see area 2 is negative. Does it make sense? Yes, because if you use you're supposed to use gx minus fx, but right now I'm still using fx minus gx. So that means the area you obtain should be negative. All right. Then what I'm going to do is my area number 3. And what would be the integral? Can you think of it? Okay, again, you need to think of. So let's go back to have a look. What would be the area number 3? So area number 3 is the green area. It should be from beta to 4. Okay. All right, this area number 2 from alpha to beta. Area number 3, which is the green part, should be beta to 4. All right, so let's do it. Beta is x2, so let's make it x2 and to 4. All right, and you'll see the value of the area here is it's interesting. let me see. Something wrong. Sorry, I just paused the video because I saw something wrong, because I make a mistake. You see the first area, sorry for the confusion. It should be -2, okay? Because I should have switched back to the screen here. So you see the first area should be -2 to alpha, not from -4. So I made a mistake here. So right now you could see the three areas. So you can see the three areas. Area, when you add up area 1 and 3, and you will see actually the sum would be equals the positive value of area 2. That means they will cancel out. Okay, so that's what we should have, because the relation, the equation line you've got here actually guaranteeing the three areas they will cancel out. Okay, how can we further track that? You can do one more thing aside the area. Oh, sorry, I need to add a note here. So let me do a side area. For the side area, we just integrate. Okay, let me use that copy and paste here. So if I integrate from start to the end, I'm using -2 to 4, then you see the answer must be 0. So that means these three areas, they will cancel out. Okay, so basically that's how can you get the area for when m equals 0.1. And okay, so then you can calculate the area in the Desmos first. Then when you go back to your manual work, actually you know the answer, so you just work through it really carefully, then you will get the answer, right? So that's part 2 of our video. In part 3, I'm going to have a generalization for all the values of m from 0.1 to 1.3. So then we will see what would be the different values of alpha, beta, area 1 and 2 and 3. All right, and so you can get all the values into the table, and use that table. You can do one extra thing. All right, okay. So I'm going to stop here. So thanks for watching, and we will get you to watch another one.